All right, so 22.54. So we were looking at 22.54A. So we want to make this amide from benzene. Well, the first disconnection is probably the most abundantly clear of all of them, and that is, if you wanted to make this compound in terms of retrosynthesis, you could think about installing the acyl group, right? Because we talked about acylation. That was one of the whole subjects of this class. So then, if you wanted to have this methyl group on here, well, you could do that by reductive amination, right? So if you had what would this be? Benzolamine, and you did a benzolamine, and you did a reductive amination. So reductive amination on this, and of course this one is acylation, right? Then you could just do a reductive amination with formaldehyde to get this, and you can see that you would get the benzolamine from a nitrile, right? We actually looked at this compound in the review of the reactions, right? If you took benzonitrile and reduced that with lithium aluminum hydride, that will give you the amine. So maybe it's not as complex as I was thinking, but you definitely have to do some retrosynthesis in this one. So first, let's start out by installing our nitrile group. And the way we're going to do that is we're going to use Sandmeyer chemistry. So first, we're going to diazotize. So we're going to start with, we're going to do the nitration. My mistake. So we're going to nitrate it using nitric acid and sulfuric acid. And so we'll install our nitro group like this. Then we're going to reduce that to aniline. So we're going to use, I just chose iron and HCl to cook that up, and that gives us aniline. Then we diazotize. So we're going to make the diazonium salt using sodium nitrite and HCl, and that gives us the diazonium, which looks like this. And then we can do our Sandmeyer reaction. So we're going to treat it with copper 1 cyanide, and that will make benzonitrile. I need to put a box around my retrosynthesis here. So there's the retrosynthesis. So let's see. Let's keep going this way, I guess. So then we're going to reduce that with lithium aluminum hydride. And then, of course, the workup is not acid, but water, because if it was acid, that would make the ammonium ion, and we don't want that. We want the free amine, like this. So there's our benzylamine. Now we can do a reductive amination with formaldehyde as our electrophile. So there's our catalytic amount of acid and sodium cyanoborohydride, like that. So that will install the methyl group on the nitrogen. So now we have our secondary amine. So we've got our methyl group here. And the last step is going to be to acylate. So for that, we just need acetyl chloride. And I'm running out of space here, so I'll put it down this way. So we need acetyl chloride. And with that, we're going to end up with our final product, which is going to look a little something like this. So we have our acyl group installed on here. All right, it's quite a few steps to synthesis. Let's count. We've got 1, 2, 3, 4, 5, 6, 7, 8. 8 steps is what's required to do this reaction. So 8 steps to do this one. And I put an alternative way of doing this reaction. I'll just show you kind of my alternate method that I put here. So I'll just write here alternate route, which I would also accept. I think there's nothing wrong with this. Is if you start with benzene and you just convert it to toluene using Friedel-Crafts alkylation. So you'd use methyl chloride and aluminum chloride, and that would make toluene. And then you can do a benzylic bromination using NBS. So that's a reaction we don't use a lot in this class, but NBS will do a benzylic bromination. So you NBS and you heat it up, and that will make benzyl bromide. So once you've made benzyl bromide, then you could just treat it with sodium azide, right? You can treat it with sodium azide as your nucleophile, so sodium azide, and then you could reduce that using hydrogenation conditions like that, and that would take you to benzylamine. Either one is fine. There's nothing wrong with either of these. I just wanted to get a chance to use our diazotization chemistry and to try a Sandmeyer reaction. But either one is perfectly fine. Give me a thumbs up if you're with me on that one. Kind of a long scheme, but if you break it down, is anybody finally finding the utility of retrosynthesis? Because sometimes students don't understand it that well in Organic 1 because we only have a few. Does anybody here use retrosynthesis? Awesome. Yeah. It can really get you out of a gym, eh, Sydney? You know, you look at a product and you say, I have no idea, right? I think that if you look at this compound, to me, it looks like a pretty complicated molecule. But if you kind of take a step back, it's a lot easier to, I'll just say, I shouldn't use the word easy. I'll say the synthesis becomes more manageable. We'll say more manageable. Let's try 22.54B. So this is 22.54B. So we're starting it with B for benzene, right? So we're starting it with benzene. And this one is actually in the same vein as a problem that we looked at earlier today. We want to put a cyclohexyl group in the para position. And then we want to put a carboxyl group on the other side. Okay, we want to make a carboxylic acid. I would accept, excuse me, a number of ways of doing this. Two main ways. But if I put this group in red, would this group be an ortho or para director? Can anybody tell me? And it's not a trick question. Mr. Dion doth detest trick questions. That's what Shakespeare said. Anybody? Yeah, it's ortho para director, right? It's just an alkyl group. Yeah, absolutely. So this is alkyl. It's cycloalkyl, but it's alkyl. So therefore, it's ortho para directing, right? And this guy here, that's a meta director. And so we're going to have to put the cycloalkyl group in first. So we're going to install that using Friedel-Crafts alkylation. So we'll use cyclohexylchloride and aluminum chloride, and that will make cyclohexylbenzene. So we're going to have these two rings attached to each other. There we go. And now to install the carboxyl group, I'm going to use Sandmeyer chemistry. You don't have to. You could do Grignard chemistry if you want. I'm just going to do it that way. So first we're going to do a nitration. Okay, maybe I'll write out two steps in one here. So first step is nitration. Then the next step is going to be the reduction. So I'll put iron and jeepers, Mr. Dion, iron and HCl, and we'll cook that up. That's step 2. And then step 3, it's kind of a weird way of writing it, isn't it? Sodium hydroxide. So that will give us the aniline derivative. Sorry I wrote that in a weird way. Just did it because of the real estate that I have here. Or at least that's my excuse. So there we go. We have our aniline derivative. Now we do the diazotization. So we're going to treat this with sodium nitrite and HCl. That will give us the diazonium salt. Write out the whole thing here. So we've got our cyclohexyl group. Looks like this. And then we have our diazonium salt. Comme ça, as we say in French. Right, Jaylin? Then we're going to treat this with copper 1 cyanide to make the nitrile. And then we're going to hydrolyze that to the carboxylic acid. And there we go. Bada boom, bada bang. All right, whole thing's done just like that. Everybody good on that one? And again, you could have done that by Grignard chemistry. I would accept that as well. All right, you see what I'm saying, Audrey? You could take this compound and you could brominate it, and you could make, right, oops. You could make this compound here and then do Grignard, I'll put here, etc. to get to the final product. I would accept that too. Either one is fine. But again, this is chapter 22, so we'll try to stick to the material. So let's go to question 22.57. Just stick this guy here. So this is 22.57, like that. There we go. All right, so 22.57. Some interesting reactions here. I like this question. This one kind of tests your ability to make disconnections and connections. So we've got this compound here. We want to treat this with excess iodomethane. And in the next step, we're going to treat that with silver oxide, water, and we're going to cook that up. Did I do it incorrectly here, 22? Because I had done this question a while ago. Yeah, it says predict the product of each of the following reactions. So let me write this down here. Predict the product. So this is Hoffman elimination conditions. Well, there's no Zaitsev product to even worry about here, is there? It would be impossible. But we could write down the intermediate that would be formed, couldn't we? And remember, you get exhaustive alkylation with your methyl iodide, so that's going to make this ammonium ion here like this, okay? And then you swap out the iodide for the hydroxide, so you end up getting silver iodide precipitating, and so your base, which is going to be the hydroxide ion, is going to come along and it's going to rip off a beta proton. So if this is alpha, this would be beta here. So we could just scribble in a proton in green here maybe. And then I can use my red pen and say, well, we're going to rip off this proton here. And then we're going to put a lone pair back on the nitrogen like this. All right, so let's draw what the final product is going to look like. And we're going to have to count the atoms here. So we've got 1, 2, 3, 4, 5, 6, 7. And the double bond is going to be between atoms 6 and 7, or carbon 6 and 7. So if we go 1, 2, atom number 2 is a nitrogen. It's also got a methyl group, or sorry, it's got a hydrogen on it that I didn't pencil in. So let me just scribble that in here like this. Sorry, no, I made a mistake, didn't I? It's going to do exhaustive. Let me just double check something here. Oops. I just need to look in my... Shoot. God damn it. Sorry, I did miss a methyl group, didn't I? That's my mistake. All right. Yes, I had a hydrogen written on there, and then I put a methyl group in the end, and I'm like, well, that's not right. So I should have put, instead of a hydrogen here, so if you're wondering what's your mistake, it's this here. I should have put another CH3 group here like that. That would have made a lot more sense. So that's why I'd written it correctly the first time, and then I second guessed myself. So you have 2 methyl groups here. So if we go 1, 2, 3, 4, 5, 6, 7, like that. There we go. And then the double bond is between atoms 6 and 7. Does that make sense, everybody? Now that I fixed it, my exhaustive methylation. Give me a thumbs up if you're with me on that one. And then you deprotonated the beta carbon. Okay, good. All right. There we go. The next one is a Gabriel synthesis. So let's give that one the old college try. You know that's going to show up on the quiz. Gabriel synthesis is a real classic. So we start with our phthalimide. And then in the first step, they do the whole thing. They do the treatment with base, do the deprotonation, right? And then treatment with ethyl bromide. Ethyl bromide. And then treatment with hydrazine at the end. So I'll just solve the first 2 steps with you. So just remember, you make the conjugate base of the phthalimide, and then that acts as a nucleophile, right? A really good nucleophile, as a matter of fact. So then you just install the ethyl group like this. And then when you treat it with hydrazine, so NH2, NH2, that will blow apart everything in the molecule. So it gets rid of all of this, get everything except for the alkyl group and the nitrogen. And so this is just a way to make ethyl. Oops, where's my black pen? It's just a way to make ethylamine. I don't know why you would do the reaction this way. There's other ways to make ethylamine, but either way, it's neither here nor there. All right, let's try the next one. So this is 22.57C. 22.57C. And I'm starting with cyclopropyl bromide, cyclohexyl bromide, jeepers. First step is to treat it with sodium cyanide and DMSO. So DMSO, remember, this is a polar aprotic solvent. Therefore, it's going to do an SN2 reaction in the first step. So in the first step, you're going to end up with cyclohexyl nitrile. And then in the second step, we're treating that with aqueous acid. So it's just aqueous acid and heat. And we make cyclohexane carboxylic acid like this. The next step is to treat it with thionyl chloride. And that's going to make the acid chloride, kind of reviewing some chapter 20 chemistry here. And then in the last step, we treat it with excess ammonia, NH3 like that, and that just does a nucleophilic acyl substitution followed by a proton transfer, and you make cyclohexane carboxamide would be the name of that compound. Then if we look at D, so in D we're starting it with benzene, and we're doing a bunch of steps here. Let's just do them all one at a time. Maybe we'll do the first three. So we're doing nitration in the first step. Okay, in the second step, we're doing a reduction. So we've done this several times today. And then a neutralization with sodium hydroxide. And that is going to give me my aniline molecule. So I make aniline like this. And then I do a diazotization followed by treatment with copper 1 cyanide. So first step is going to be sodium nitrite and HCl, and second step is going to be copper 1 cyanide, and that is just going to make benzonitrile. Nothing more to it than that. Benzonitrile, just like that.